Think about your daily routine for a moment. From the second you wake up to the moment you go to sleep. Your entire life is quietly controlled by numbers. Your phone shows battery percentage, your bank account tracks every rupee, and your GPS tells you exactly where you are on this planet. None of this feels special anymore because it works so smoothly, so perfectly that we don't even question it. But now imagine something goes wrong. Not with the technology, not with the machines, but with the very logic behind numbers themselves. Numbers still exist. But if one fundamental idea disappears, suddenly calculations will stop making sense and systems will begin to collapse one by one. Flights cannot be scheduled properly, financial transactions become inaccurate and unreliable, even basic counting starts feeling confusing and broken. This might sound unrealistic at first, but what it actually shows is how fragile our modern world truly is. Because everything we see today, every system, every calculation, every prediction, stands on a few powerful ideas built centuries ago. And one of those ideas was not discovered in Western or Europe, but developed and refined in ancient India. Yes, around 1500 years ago, when most of the world depended only on what they could see, there was a man who chose to question what everyone believed. No telescope, no advanced instruments, no massive observatories or digital tools. Just patterns, logic, and an incredibly sharp mind. While people believed the earth was completely still and that the universe revolved around it, he looked at the sky and saw something different. He realized that the movement we see above us is not because the stars are moving, but because the earth itself is in motion. Now think about that. At a time when even questioning such beliefs was unthinkable, this was nothing short of revolutionary. It challenged what people saw, it challenged what people believed, and most importantly, it challenged how people thought. That man was Aryabhata. Namaskara everybody. To truly understand his journey, we need to step back and look at the world he lived in. Because great ideas are never born in isolation. This was the time of the Gupta Empire, a period often described as a golden age of knowledge. Science, mathematics, art, and philosophy were all evolving rapidly. Cities were not just places to live, they were centers of learning, where ideas were discussed, debated, and refined. Scholars did not stay limited to one region, they traveled across lands, bringing new perspectives and exchanging knowledge. One such important center was Kusumapura, a place that played a key role in intellectual growth and became a hub for curious and questioning minds. This is where Aryabhata is believed to have lived and studied. Surrounded by discussions, debates, and constant learning, his thinking began to sharpen at an early stage. He was later associated with Nalanda University, one of the most advanced institutions of its time, a place where knowledge was not just taught, it was expanded. By his early 20s, he was not just learning anymore, he had already developed deep expertise in mathematics and astronomy. And then came a bold decision. At just 23 years old, he chose to organize his knowledge into a structured work. Not just notes, not scattered ideas, but a system of thought that could be understood, studied, and carried forward. At just 23 years old, he did not just study knowledge, he decided to preserve it in a way that the world would remember. This work came to be known as Aryabhatiya, a text that may look small in size but carries ideas far ahead of its time. Now here's what makes it truly interesting. Unlike modern textbooks filled with long explanations, this was written in a completely different style. There were no lengthy paragraphs, no step-by-step breakdowns like we see today. Instead, everything was written in short, precise verses. But don't mistake simplicity for lack of depth. Each verse was carefully designed to encode complex scientific ideas into a compact form. Why? Because during that time, written copies were rare and difficult to preserve. So knowledge had to live in memory and not just on paper. And these verses made that possible. They were structured in a way that the scholars could easily memorize and pass them forward. But what he chose to include in this text is what truly shows the scale of his thinking. It was not limited to one subject. It covered multiple areas of knowledge, from time cycles and arithmetic to planetary motion and geometry. Different domains yet connected through logic, all organized within a single framework. Every section had clarity, every concept had structure, nothing felt random or scattered. It shows one important thing. This was not just knowledge, this was deeply disciplined thinking. Even today, scholars and researchers continue to study these verses, Not because they are unclear, but because they're so dense with meaning that every line reveals something new when you look closer. One of the most powerful contributions of Aryabhata was not just a discovery, but in a shift in how we understand reality itself. At that time, people believed what they saw. If the sky looked like it was moving, then for them the sky was moving. It felt obvious, it felt natural, and no one really questioned it. But Aryabhata did not stop at observation. He went one step deeper. He separated what we see from what is actually true. He suggested something very uncomfortable, that human perception can be misleading, and what appears real may not be the reality at all. Now think about how bold that is. Not just challenging an idea, but challenging the way people think. And to explain this, he used a simple yet powerful concept: relative motion. Imagine you moving forward in a vehicle. When you look outside, the trees and buildings seem to move backward. But are they really moving? No. It's your motion changing your frame of reference. This simple observation became the foundation of a much bigger idea. Using this logic, he explained that the Earth is not stationary. It rotates on its own axis. And because of this rotation, the Sun, the Moon, and the stars only appear to move across the sky. What people believed was the movement of the universe was actually the movement of the Earth itself. And here's what makes this even more remarkable. This idea came centuries before Nicolaus Copernicus introduced heliocentric concepts in Europe. But the real brilliance is not just the conclusion, it is the method behind it. Aryabhata did not rely on powerful instruments. He did not depend on complex technology. He relied on logic, on observation, followed by questioning. Another area where Aryabhata brought remarkable clarity was something that once filled people with fear: the phenomenon of eclipses. At that time, eclipses were not seen as scientific events. They were often surrounded by myths linked to supernatural forces and unknown powers. For many of the people, an eclipse was not something to understand, it was something to fear. But Aryabhata looked at the same event from a completely different perspective, not through belief, but through observation and reasoning. He began with a simple idea. The moon does not produce its own light. It shines because it reflects light from the sun. Now, building on that logic, he explained what actually happens during an eclipse. When the earth comes between the sun and the moon, its shadow falls on the moon, and that is what we call a lunar eclipse. And in the same way, when the moon moves between the sun and the earth, it blocks sunlight from reaching us, creating a solar eclipse. No mystery, no supernatural force, just alignment and shadow. This explanation did something powerful. It removed fear and replaced it with understanding. It showed that even the most dramatic events in the sky can be explained with logic if we are willing to question what we believe. Beyond astronomy, Aryabhata made contributions that reshaped the very foundation of mathematics itself. One of the most well-known examples is his work on the value of pi, a number that quietly exists in everything, from circles to complex engineering. He calculated its value with a level of accuracy that was extraordinary for his time. In fact, the value he reached was very close to what we use even today. But here's where it gets deeper. He did not just calculate pi, he understood its nature. He indicated that pi is not a terminating number, which means it does not end. Its decimal form continues infinitely, without repeating in a simple pattern. Now think about that. This is not just calculation, this is insight at a completely different level. Because understanding infinity is far more complex than just writing numbers. And that was not all. He also played a crucial role in developing the place value system. A system so simple on the surface yet so powerful in its impact. It allows numbers to be expressed based on their position. Units, tens, hundreds, thousands. This structure is what makes calculation efficient. Without it, even basic arithmetic would become slow, confusing, and unnecessarily complex. Imagine trying to calculate large numbers without place value. What feels easy today would feel almost impossible. And here's the real connection to our world. The digital systems we depend on today, computers, programming, financial systems, all rely on this structured way of representing numbers. A system built on logic, precision, and clarity. So when we are talking about modern technology, we're not just talking about machines. We're talking about mathematical ideas that were shaped, that were built centuries ago. The ideas of Aryabhata did not stay in one place. They refused to be confined by geography. Over time, his work began to travel, crossing languages, cultures, and civilizations. Scholars from Arab world recognized the depth of his ideas and took the effort to translate his work. This was not just translation, it was transmission of knowledge from one civilization to another. And once these ideas moved forward, they did not stop there. From the Arab world, they gradually reached Europe, influencing the way scientific thought began to evolve. Concepts were studied again, interpreted in new ways, and slowly integrated into different systems of learning. Even today, some mathematical terms and approaches we use carry traces of those early ideas. They may look different now, they may have evolved over time, but their core remains the same. And that brings something powerful. Knowledge does not belong to one culture. It moves, it adapts, and it connects civilization. Because when an idea is truly valuable, it does not stay in one place, it finds its way across the world. Despite all these achievements, not everything survived the passage of time. And that is where this story takes a painful turn. A large portion of ancient knowledge was not preserved. It was lost. Sometimes slowly, sometimes in a single moment. One of the most tragic examples is the burning of Nalanda University, an event that led to the destruction of vast libraries filled with centuries of collected wisdom. Think about what that really means. Not just books being burned, but ideas disappearing forever. Manuscripts that held discoveries, theories that were ahead of their time, and knowledge that could have changed our understanding even today. All of it reduced to ashes. And what remains with us now is only a fraction of what once existed. Imagine watching a trailer that was not fully released. And that is what happened to us. And that leaves us with an important realization. Knowledge is powerful, but it is also fragile. It needs to be protected, preserved, and passed forward. Because once it is lost, it may never return again. Even after centuries, the influence of Aryabhata has not faded. It has only evolved. His ideas did not remain locked in the past. They continued to inspire, quietly shaping the future in a way that we don't even realize. India's first satellite, Aryabhata's satellite, was named in his honor. This was not just a tribute, it was a statement that the journey of the discovery started is still ongoing. And today machines like Chandrayaan carry the same spirit forward. A spirit of curiosity, a spirit of questioning, a spirit of exploring the unknown. What began as observations of the sky with nothing but logic and imagination has now reached the moon and beyond. And that's the real legacy. Not just discoveries, but inspiration. Because powerful ideas don't end with one person, they move forward with generations that dare to think even bigger. The story of Aryabhata is not just about discoveries, it is about a way of looking at the world. He lived in a time without advanced tools, without modern technology, and without access to endless information. And yet, through observations and reasoning, he arrived at ideas that were far ahead of his time. He questioned what seemed obvious, he looked beyond appearances, and he tried to understand what was actually happening. Today the world looks very different. We are surrounded by systems, data and technology that operate at a level he could never physically access. But at the same time, the foundation of many of these systems connects back to ideas shaped centuries ago. That contrast is what makes this story interesting. Not just what was discovered, but how it was discovered. Because sometimes progress is not only about moving forward, it is also about recognizing how far certain ideas had already gone.